Hey, my name's Austin. I'm with Great Northwest Installations. I'm a water heater technician. This is Oscar, and we're both here to swap out this electric water heater for a heat pump water heater. We're doing this project today through Community Energy Project to put in a more energy efficient water heater. And so what we're going to be doing today is installing a 50-gallon heat pump water heater into the customer's garage. Currently we have the existing water heater in the back corner in a kind of an enclosed closet. The new water heater will not end up going here. It will go next to us here to the side and in this kind of cabinet space. And so there's a couple things that we want to look for when we're doing an installation. And especially if you're doing an installation on your own or you're looking to do kind of a DIY install of a heat pump water heater, there's a few basic things you're going to want to look for. The first thing is your power source. You're going to want to know if you have the appropriate amperage at the breaker panel. Do you have wiring? If you're switching from gas to electric, you want to make sure that you have appropriate power for the water heater. And then a couple other things you want to look for are plumbing. We're going to be taking some of this plumbing in the closet here and relocating it and moving it over for our water heater. And then the other thing, because it is a heat pump water heater, it will have a condensation line that needs to be ran that is unique to a heat pump water heater. In our case, we have a garage wall that is the exterior wall of the home, so we're going to be able to take that condensation water, drill a hole to the exterior, and have that condensation water evacuate to the outside. The last thing that you want to be concerned with are the manufacturer's installation instructions. I would always make sure that you're referring to that when you're doing your own installation and follow your local codes. All right, so the first thing that we want to look for to verify is our power source. Right behind me here, we have our breaker panel, and on this panel we have a switch that's labeled for water heater. If the switch is correct, which most of the time it is, but sometimes you're going to need to do a little troubleshooting to make sure that you have the right switch, we have already shut that off. And then the next thing that we're going to want to do, we're going to want to take a voltage tester and we're going to check the power for this and make sure that it's off. If it beeps, it means that we're still live and we may not have the correct breaker in the panel. If it's green and we don't get any type of indication on the voltage pin, then we're good to go ahead and remove those wires. While he's taking the lid off, the electrical wiring is right underneath the lid. Because of that, just be cognitive and be safe. Don't stick your hands right in there where the wiring is. The next thing that we're going to want to look for, you do want to check your water pressure in the home. You're going to want to look for whether your home is on an open or a closed plumbing system. Why that's important? Most local plumbing codes will require you, if your home's on a closed plumbing system, to put what we call a thermal expansion tank on the water heater. The thermal expansion tank essentially is a reservoir and a rubber bladder that expands and contracts to take on thermal pressure. So it is important to have, if it's open, that means that water pressure is able to flow back and forth to the street. That's indicating that we do not need that expansion tank. So we're going to take our pressure gauge out to one of the hose bibs in the home. There's one in the backyard. We're going to check our water pressure. If the black needle pegs and hit a specific pressure very quickly and then doesn't want to fluctuate after that, that's going to tell us we're on a closed system. If that gauge is going to sway back and forth and then sort of settle down to its pressure, that's going to tell us that it's open, and then we can make our determination. So we're going to take this hose off, just move that off to the side. So we start with turning these off. I like to have kind of a T configuration. That way we can run water through the other side to sort of help us see and read what this gauge is going to do. Now I'm going to open up the side that doesn't have the gauge on it here. Then I'm going to open up the other side. So that pressure gauge went pretty quickly up to about 63 pounds or so. That's telling me that we're on a closed system. If you want to test it again just to see, you take the other side of the T, run some water, let it go, see how that gauge is going to behave. We're pretty much ready to start draining the water heater of its water so that we can get the disassembly process going. It depends on the current installation. Where your current water heater valve is located may determine whether you turn your main water off or you just turn the water off at the water heater. We do have a cold water shutoff here on the tank. The reason why that's not going to work for us today is because we are going to be changing some of this plumbing and moving it into this closet, which means we're going to have to work behind that water shutoff valve, which is going to require us to turn the main water off to the home. If you don't have to do anything with that valve, you may just be able to shut that off, do the installation, and then turn it back on when you're ready to fill the tank. But we're going to turn the water off at the main out at the street. Before we turn the main water shut off to the house, we're gonna hook up a water transfer pump first. This isn't necessarily required. If you're able to just kind of gravity feed your water through a garden hose, you don't need to have this pump, but it does speed the process up. So we're gonna put that pump in between here and the hose. That's gonna help pull that water out of the water heater quicker. We have a 50-foot heavy duty hose here. You should have a garden hose that's rated for hot water. Some of them are not. And we're gonna wanna just take this hose and we're gonna run it out either to your yard, your driveway, somewhere outside the home. All right, so we're about ready to turn our water off. One thing that does help to get the water started draining through this hose and through our pump is we will actually end up opening up this drain valve on the water heater first to get water flowing, just in case you have any mineral or rust in the water that may potentially want to clog that drain valve. Okay, so you've got water flowing. We're gonna go out to the street now and we're gonna turn the water off to the house. We are out here at the water meter box located near their sidewalk. Yours might be in a different place, maybe in your front yard. You're gonna wanna find your water meter if you wanna turn the water off this way. Sometimes you'll need a screwdriver to take the lid off just to be able to pry the concrete or the lid off of the box. And then we have a water meter shut-off key. It's just a T-handle. You can get one of these at your local hardware store. It's got a little handle on the end of it that is meant to turn that valve off in your water meter box. So we're gonna open that up. All right, we take our handle, our T-handle key, and we're gonna turn it clockwise to turn it off. All right, so we do have the water shut off to the house, and we are ready to start taking things apart on the water heater. A couple of the things that you might remove if you're doing this on your own, there might be some existing kind of earthquake strapping or bracing that you're gonna need to take apart. The plumbing needs to be disconnected in order to remove this. And then of course the water needs to be drained out. So we are ready to do that now. Oscar's going to turn our transfer pump on. It's going to start pumping this water out of the water heater. And the other important thing that we need to do to break the airlock in the tank is we do need to open up our temperature and pressure relief valve on the old water heater. It's here on top. Sometimes they're located on the side. We're just going to pull this lever up here. And that's going to introduce air into the tank, which is going to allow the flow of that water to improve and speed up the draining process a little bit for us, especially if you don't have a transfer pump to help get that water out. There we go. All right, so the tank just finished draining. If you do use a transfer pump, you can kind of hear the noise of the pump will start to change as the water is kind of finished going through it. At that point, you know that it's done, or if you just have your hose hooked up to it, the water will stop draining through the hose because you'll be all done. It is good to have a hand truck or something that you can move the water heater around with so you don't hurt yourself. We're just gonna try to slide it out and then we'll use the hand truck, get it underneath there and we'll roll it to our truck. You can recycle these in a metal yard if it's new enough and you're just proactively replacing. You know, maybe somebody in the area or somebody you know may need the one that you have and maybe you can donate that to them. But we will end up recycling this due to its age. It's about 25 years old. At this point, if you're doing this on your own, this is where you start prepping your plumbing and figuring out how you're gonna run your condensation line, your earthquake straps. Those are things that need to get done before the water heater gets put into place. We'll need to take that old expansion tank off the wall, which is still mounted up there. After we do that, we're gonna take our hot and our cold plumbing and we're gonna drill a couple holes into the new location to bring that plumbing this way. And then we'll get our earthquake straps prepped in here and then we'll go from there. Okay, so we're still in the kind of prep work phase of getting our plumbing moved over. While I'm doing that, Oscar has started to get our expansion tank pumped up. So when we took our water pressure earlier to see what that incoming water pressure was to the home, that is what you pump the expansion tank up to with an air compressor. A bicycle pump could work, but it honestly takes a lot of effort. So you're gonna pump that up to whatever that incoming water pressure was so that it can properly expand and contract with that thermal expansion that's gonna be created by the heater. If you don't pump them up correctly to that pressure, you could see premature failure of your expansion tank. So you just wanna make sure you pump it up to that incoming water pressure. We have the old water heater taken out. We have the plumbing readjusted in here and brought into the new area of where the tank will go. We have a hot and a cold line that's ready to go for us. The next couple things that we're going to do is install some earthquake strapping. You could buy this at any hardware store. They do make different sizes, so if you're not doing a 50-gallon water heater and you're doing like an 80-gallon or something larger than that, they do make larger straps to accommodate. We also have the expansion tank pumped up already. That is going to get mounted onto its own bracket also. So yeah, we're going to start working on that stuff now and getting the rest of this prepped and ready to go. So right now we're putting our earthquake straps into the wall. You do want to find studs, preferably. If you're in a basement, you're dealing with concrete, you can do hammer-in anchors, something to hold it onto the concrete. The code does require that you put your earthquake straps on the bottom third and the top third portions of the water heater. All right, so a couple other things to consider now that we're where we're at. We want to also consider the surface that we're putting the water heater on. We are in an unconditioned space in this garage, so we're not located in the home. Because of that, we will need an insulator underneath the tank. What we use for that is a high-density styrofoam board that will go underneath the tank. We are on a wood surface, and because we're on that wood surface, we'll also need to put a pan underneath the water heater to make sure that if that tank were to ever leak, that pan will catch that water and direct that water to the garage floor instead of right onto the wood surface. That will rot the wood over time. We can also continue prepping our plumbing to get ready to put that water heater into place, and also run our condensation line for the water heater. That way we have room to work. That's one of the things you want to make sure that you do, is think about all of the different things that may get in your way once that water heater is in place. You really want to make sure that everything that you need to have prepped is prepped and ready to go in the case that you can't reach those things once the tank is already there. All right, so we got our hole made. We know that we're in a good spot. We don't have anything on this wall. The only thing that is preferable is if you have a side of the home that maybe has grass or dirt, gravel, that's ideal. These units condensate all year round if you're running it on heat pump mode. And so you are going to get some trickling of water happening on a concrete surface, which can freeze in the wintertime. This is a pretty unused side of the house, and it's not a major walk path, so we're not too concerned with where we're at. All right, so we have our holes drilled for our condensation line. Just wanted to go over the materials real quick that you might want to be using for this. We're using CPVC. It's a chlorinated PVC. Some people might use PVC. Copper is another approved material. This is probably the most user-friendly. It just requires a one-step yellow CPVC glue cement. This is what we use to put it together. You just dab some on your pipe and on your fittings. You push them together. You hold them for about 20 to 30 seconds each, and that's going to create your watertight seal. So we have our high density styrofoam pad. This has an R10 insulation rating to it, so it is going to make sure that that bottom of the tank is fully insulated. So we're going to go ahead and put this down first. And then our pan where we want it, which is going to be something like this. And then we're going to pick the water heater up, and then we're going to drop it into that pan. What I do with my hand placement is I'll have a hand here on our TMP valve. Sometimes I'll reach all the way across the tank to help me lean it back, or grab one of the nipples on top of the tank if you have them. It really depends on the model that you're working with. Sometimes this will be over here, so you kind of have to work with what you got sometimes. They do make straps and stuff that you can strap around these to help you have some handles. But what we're going to do for this one, I'm going to put a hand here, and I'm going to sort of get it in position in order to lean it back onto my leg. I'm going to try to keep my back straight the best I can, and we're going to lift that back end up and pop it into the pan. So I'm going to lean it back, get it leaned forward, and I get kind of almost a lunge type of a stance here, and then I'm going to just rock it on my knees here like so. And then we pop it in and raise it up. And at this point, we're gonna kind of slide everything back, hook up our earthquake straps, and make sure that all of our stuff, our electrical, our plumbing, our condensate lines, all gonna reach how we intended it to reach before you start, hooking everything up to it. This is a 9/16 ratchet wrench. You don't have to have this, but it does help. So this is just gonna help you get those nuts secure on the bolts. You can over tighten these, so you don't wanna go too tight. You really just wanna make them snug. The easiest way is that if you take these and you add some force and try to wobble them up and down, they shouldn't move. This drain in our current location needs to go to the garage floor. So we need to run this drain down and make sure that it's pointed towards the concrete. If this were to ever discharge, which it's not supposed to, it's only an emergency drain. If the tank overheats or gets overpressurized, it will start to drip or discharge water. So we want to make sure it's on the concrete, not damaging the wood surfaces here. It's just making its way that direction. You have a drain valve at the bottom of the tank here. That's so that you can do your routine maintenance, yearly flush or your drain of the tank. And then our pans down here at the bottom. There's a drain line here that we're also gonna hook up. Just a short piece of pipe that also needs to get directed onto the concrete. And then lastly, this is gonna be our condensate port here on the side. And we're gonna bring that drain and hook it onto what we've already got pre-installed. The important thing with our condensate drains, we really wanna make sure is that they do have at least an 1/8 inch per foot gravity feed going down. You don't want them flat and you don't want them going backwards. That condensation water will get caught up in certain areas. And if you do that, the slope going the wrong direction in the wrong place, you can have that water back up into this tray in here and you will get leaking condensation water going down the tank. And then last but not least, on our expansion tanks, we've made it accessible. What you're gonna do here is at least once per year, you're gonna push the little needle pin on the inside of that to see if you got any kind of water that's gonna discharge from there. The water is gonna tell you that the expansion tank has failed. And then we have our plumbing to hook up here. This is gonna be our cold feed and our hot's gonna go to here. The PEX is nice to make different colors. So we have conveniently blue PEX and we have red PEX. That just helps us indicate our hot and our cold. For our plumbing connections, we're using stainless steel water flexes. Both sides of the water flex are gonna be a female thread. They're union connections, so they do have washers in them. So typically we don't need to add any type of thread tape or pipe dope onto our water heater nipples. This particular model, we seem to kind of get those to leak more often, so it doesn't hurt to add a little bit of that on there just to help create a good seal. So that's what we're doing here. And then we're just using a crescent wrench to tighten those down. Typically with your drains going to the exterior of the home, the bottom of that drain pipe, you want it to be about 6 to 12 inches off the ground. So we're just gonna cut it close to the wall, put an elbow here, and bring it straight down. The only other thing we would do here is wanna make sure we seal up all of our holes to the exterior. So we're gonna do some type of a caulking around that hole to make sure we don't get any airflow leaking into the garage. The last thing that we have to do is hook up our electrical for our power. And then before we turn anything on, we are gonna fill the tank up with water first. That's a rule of thumb. When you're turning on any gas water heater, electric water heater, you always wanna make sure that the tank is completely full of water. We wanna make sure all the air is purged from the plumbing in the house. Typically for your electrical, you need a couple of wire nuts that fit wire that's going to be about 10 to 12 gauge wire to connect your hots together. You should have 2 hots in a ground. And then once you have that all hooked and secured on here and the tank's full of water, then we can turn on our power. All right, so for our current situation right now with the wiring, we do have 4 wires inside of this Romex instead of 2 hots in a ground, which would be our 3 wire. So usually when you're hooking these up, you only need 2 hots in a ground. So what we're going to end up doing in this case, just to make this work for him, we would recommend, if you run into something like this, it is better to just have an electrician replace this wiring altogether. This is something that we can hook back up to the tank and it will run the way that it's supposed to run, but we just have an unnecessary third wire in here. So what we're going to do with it, we're going to leave it like this, and we're going to throw a wire nut that's smaller to kind of plug that wire up. All right, so one thing with your wires, when you strip these back, you don't want to strip too much of this wire coating off to where you have any of that copper exposed. Because if any of this exposed copper, if you cut back too far, touches a metal surface in here, it's going to arc and you're going to get a tripped breaker and some black smoke and stuff coming out of here. So all dangerous stuff that we don't want to happen. How the water heater wires are already configured is about what they should look like. So that neutral wire, just gonna go ahead and put that wire nut on it, get it down into our box. In this particular case, we're gonna match up black to black, red's gonna go to red. If your wire coming from the wall that's gonna go into the tank, maybe you have a white and a black, that's totally fine also. Your blacks are always gonna go together and your white will match up with the red in that case. And then you do wanna make sure that you line up the ends, hold those wires firmly in place so one of those wires doesn't back out. If one backs out, you may think that you tightened it down enough, but one of those wires isn't actually touching the way that it's supposed to. And you essentially want to go tight enough on these that your wires will start to kind of overlap each other. At that point, and they feel nice and hand tight, you're good to go. All right, so we are almost done with the installation. We have our hot and our cold lines both connected to the water heater. Our new water heater valve is in the off position. We got our drains, condensation drain, temperature and pressure relief drain, all hooked up and ready to go. We are ready to turn the water back onto the house and get this water heater filling with water. So we'll leave our water heater valve in the off position. We'll go turn the main water back on, come back over here and see to make sure that all of our plumbing connections that happened before that valve are leak free. After we've checked on that, we're gonna go ahead and open that water heater valve up slowly. That's gonna allow water to start filling up in the water heater until we're all the way up to full. And then we're gonna position a bucket. It can be something smaller than this, a small tray to catch some water. We're just gonna use a 5-gallon bucket for now. And we're just gonna tuck this pipe into the bucket like so. And so what's gonna happen is when this water heater fills up with water and we get all the way up to this point with this valve in the open position, like so, it's gonna allow that some of that air in the tank to just kind of discharge into the bucket. As soon as we hear water, we're gonna go ahead and flip that spring back into the closed position and close this. That's gonna allow water to start entering the plumbing in the home. And then once that's done, we'd have the homeowner go through the house and open fixtures up slowly, one fixture at a time, open up the cold side, purge the air out of the plumbing, close it, open the hot side of the fixture, and make sure all of those air bubbles have made its way through until you get regular water flow. We're gonna slowly open this up. Okay, so now we've got full water pressure entering the tank. So the next step is very important that we do this, is we're gonna wanna open up our temperature and pressure relief valve. We just pull up on this lever here. It's gonna open that spring, and you should hear a bunch of air start to go through that bucket. And then once this tank fills up, we'll hear water start to gurgle through that pipe. And once we allow some water to kind of work through that temperature and pressure relief drain, we're gonna shut it off. And then we'll go through the house and we'll purge the air out of the water lines. All right, so we have pretty much finished the installation of this heat pump water heater in the garage. The tank is full of water. We've purged all the air out of the plumbing inside the house and gotten good water flow at all our fixtures, so we can confidently say that our plumbing system is fully pressurized. We've also added some pipe insulation onto all of the plumbing in here. Everything is hooked up and full of water, so we're gonna come over to our breaker panel, find our water heater switch. It's the only one that we've turned off today, and we're gonna go ahead and flip that over to the on position. So lastly, when you've completed your installation, one thing you want to make sure you do is consult with your local jurisdiction to make sure that you've gone through the steps to fully permit your water heater. So you will want to go, go to your local .gov website and consult with them and figure out how to get your water heater permitted, so somebody can come out and take a look at it and make sure that you're squared away and everything's done correctly. So with this particular model, once we've turned everything on, we're gonna get a screen that says disabled on it. What we do first is we're gonna go ahead and hit the on button. Now what we see is 120 degrees, which is the set temperature of the water heater. And now it hasn't fully turned on yet until we do one more step, and we're gonna push the mode button. Now that we've pushed the mode button, we've activated it and put it into energy saver mode, which is the default mode that this water heater comes in. And now it has begun to heat water. You do have an indicator on here that says heating when it is actually heating. So it'll show you here that we're heating. It says energy saver. That's commonly used as hybrid mode on other products. What this mode is gonna do is gonna be the best of both worlds for your energy savings and hot water recovery. So in this mode, you're gonna get decent performance and you're gonna get great energy savings out of it as well. If we hit the mode button, the next one on this water heater is high demand. High demand mode is gonna be not so much an energy saving mode as much as it is a high performance mode. So in this mode, we're cutting back on the energy savings, but we're adding performance. We'll hit the mode button again. We have heat pump mode. So heat pump mode turns these elements completely off, and it just utilizes the heat pump, which is this top portion of the water heater. This is the most energy efficient mode that these water heaters provide. It just will take a lot longer to heat the water. Hitting the mode button one more time, we got electric mode down here on the bottom. The heat pump no longer does any operating whatsoever. The elements do all the work to heat the water. So just like the old electric tank that we had over here, it's now behaving exactly the same. This mode is good for if you ever do run into some kind of an issue with the heat pump. You get an error code and it does not want to heat the water because the heat pump needs to be serviced. You can put your water heater into electric mode and get you hot water until a service technician can come out and address what the issue might be. So we'll hit the mode button one more time. We have a vacation mode. That's the last mode this water heater gives you. It keeps the water lukewarm in the tank. So while you're gone on a vacation for, let's just say 14 days, we can heat up our water to 50 or 60, and then it will heat back up once that timer is done and you've come back, right? So we're saving a little bit of electricity there. A couple other things on the display. You do have a next button here, enter, Wi-Fi, a clear alarm, and on and off. The next button takes you through some menu options. The Wi-Fi button, once you select that, you can, basically everything I just showed you, it allows you to do all that from your phone. So you can change the temperature, change the modes, see what kind of operating costs maybe your water heater is using. All of that can be done through your phone. So it is a nice feature to have, but you do not have to have it in order to have the water heater. So if you're not tech savvy, it's not necessary. Important other note here, you have an up and a down arrow. That's your temperature control. So no longer do you need to go to the top element cover, unscrew that, and turn the dial to turn your temperature just like the old one. We don't need to do that here. You're just gonna go up here to the plus button and increase the temperature 1 degree at a time. Okay, so anything above 125 is typically considered a scald risk. All your water heaters, somewhere on the side will have a sticker on it that will tell you 125 and above is considered a scald risk. Okay, so we'll bring it back down to 120, and that's your typical controls for a heat pump water heater. A couple other things to mention as far as maintenance on your heat pump water heaters. Typically you are gonna have some kind of an air filter that's gonna catch any air debris, dust in the air, dryer or lint, wherever your water heater might be located. And that's gonna be somewhere around where that intake area of the water heater is. So the intake area is in the back. So when this water heater is pulling in air and exhausting it through this fan, you do want to try to allow for at least a foot above your water heater. So if it doesn't come all the way up and be able to come out, you're just going to kind of flex that sideways here, and then your filter will pop out like so. So this is not something that you ever have to go buy a new filter to replace. It's a washable plastic mesh filter. So you're just going to take this filter, you're going to take it to a utility sink or a sink in the home, rinse it with cold water, rub that dust off of there, let it become mostly air dry, and then you can slide it back into place. The other thing for maintenance that you as the homeowner will want to do is some kind of a yearly or bi-yearly flush or drain of your water heater. A lot of times the owner's manual may give you that information on how they'd like you to drain or flush the water heater. I would advise follow your manufacturer's installation instructions. All you really need for this is a garden hose. You attach the garden hose down here to the drain valve. We hook up the drain hose, run it to the outside of the house. We're going to want to turn the power off to the water heater. And then once you've done that, you can leave your water turned on to the unit, open that up with the screwdriver or by hand, however the valve functions, and let that water pressure of that incoming water start to push water through that hose, basically pushing out any sediment or rust buildup that may be occurring at the bottom of the tank. That's the area of the tank where there's the least amount of movement of that water. So in order to keep the inside of the tank clean, you want to do that flush once or twice per year. Once you've drained or flushed water through that hose for a couple of minutes or the water looks clear, you just come back to the tank, turn that valve back off, remove your hose, and turn your power back on, and you're good to go. We are done with the installation. So we just want to say thank you to Community Energy Project and other programs out there that help homeowners provide this type of energy efficient product so that they can get the hot water that they need at a great price. If you are somebody that needs some help and assistance from a program, look around, do some research. Community Energy Project's there for you. There are other programs that can be of assistance in order to help homeowners get what you need in the house so you have hot water and you have an energy efficient product that works for you. Yeah, and with that, we're all done. Thank you guys. It was a pleasure putting this water heater in.
Thank you.